In this short video, I'm going to show you guys how to solve for the eigenvalues and eigenvectors. I'm going to use an example from page 113. So with all eigenvalue and eigenvector problems, we have a K and we have an M matrix. So the first thing that we want to do is we want to specify the variables for those matrices. So the first thing that we'll do is we'll use this matrix button, and we'll create a 2 by 2 matrix for M. So M is 1, 0, 0, 2, and we'll store that. So control variable, which is store, and we'll save that as M. We'll create another matrix for K. So now we've identified the K and the M matrices. So to get the characteristic equation, what we want to do is we want to say that K, the determinant, so det, K minus M times omega squared. Okay, so make sure you use this multiplication here, otherwise you won't get the correct answer. So determinant K minus M omega squared, and that will give you the characteristic equation. So now we want to solve the characteristic equation for omega such that it equals 0. And then we have to specify the variable, which is W. And we'll press Control Enter so that we can get some numeric answers. So you'll get two negative numbers. Those are meaningless. So we'll just look at the two positive numbers. So the first natural frequency is 0.79 and the second natural frequency is 1.53. We'll go ahead and do the same thing and save those values. So 0.796,225. We'll store that as omega 1. And we'll store the second natural frequency in omega 2. Of course, these are both in radians per second. So typically what we do is we get the K minus omega squared matrix with omega plugged in. So we'll do that. So K minus M times omega 1 squared. So this is our K minus M omega 1 squared matrix. So typically this is going to be multiplied by A1, and this one will be multiplied by A2. And we typically will assume A1 to be equal to 1. So what we'll do is we'll solve 1.36603, which is this value, times 1, which is A1, minus 1, which is this value, times A2. And that, of course, is equal to 0, and we'll solve for A2. So that's A2. So just as a reminder, our eigenvector will be 1.366. And we'll go ahead and store that as V1 just in case we ever need it. So we also need to do the same for omega 2. So K minus M times omega 2 squared. And we get this matrix. So we'll do the same thing as that we did up here. Solve. Instead of 1.36603, we have negative 0.366028 times A1, which we always assume to be 1, minus 1, which is this corner, times A2. And let's solve for A2. So our second eigenvector will be 1, negative 0.366, and we'll store that as V2 just in case we need it in the future. So just as an overview, I've showed you guys how to calculate the natural frequencies, and to get the eigenvectors, we're just following the mathematical steps that were taught in dynamics and vibrations. But in this video, I'm showing you how to implement it using your TI Nspire. If you have any questions regarding this recording or what I've explained here, please send me an email. I'll do my best to respond to you. And thank you for your time.